Hi all the students. Today we are going to see how we can find all the spanning trees of a graph in graph theory. Now we all know that a graph can have more than one spanning tree. Usually graphs have more than one spanning trees. So it is easy to find one or two spanning trees in a graph, but how do we go about finding all the spanning trees that exist in a graph? So this video is about finding all the spanning trees of a graph. That means we will figure out a way to see how we can discover all the spanning trees that exist in a graph. Usually in a connected graph. Now this particular graph that you're seeing is a connected graph. So usually in a connected graph, there are a large number of spanning trees. As I told you, there exists more than one spanning tree in any given connected graph. Now, one reasonable way to generate a spanning tree of a graph is to start with a given spanning tree, with a particular spanning tree. Now, it is very easy for any one of us to find at least one spanning tree in a connected graph. All you have to do is remove one circuit or one edge of the graph and then see if the graph still has circuit. Then you remove the other circuit also and see if there still exists a circuit, and then you remove the other circuit also and see if there still exists a circuit. See, here if I take the example how I found the first spanning tree is that first of all I removed this edge E. After removing the edge E, I still had circuits in the form of edge F and edge H. Then I removed edge F, still I had circuits in the graph in the form of edge H or edge C. Now one circuit was removed by removing edge E. Another circuit was removed by removing edge F. Now in the third step I removed edge H, but still I had circuit in the form of this triangle. So then I finally removed the edge G also, and now my graph was circuitless and hence I had a tree. So you keep removing the edges from the graph until there is no circuit left. This way you can find the spanning tree. So at least the first spanning tree of your graph you can find in this way. You remove one edge and check if there is a circuit. There is a circuit, okay, then remove the other edge. Then again check if there is a circuit. If there is still a circuit, remove the other edge also. Then see if there is a circuit. If yes, then remove the other edge also. Now if the graph is circuitless, you found your first spanning tree. So at least this way we found our first spanning tree named T1. So this spanning tree generated from this connected graph, we name it as T1. Alright, now as it is a spanning tree, you can see it covers all the vertices of the graph, and there are certain edges that have been removed to remove the circuit of the graph and hence find a spanning tree. So this is my spanning tree. A, B, D and C forms the spanning tree named as T1. Now the job is to find out other or all the remaining trees from this particular spanning tree. We found our first spanning tree named as T1. So this spanning tree is A, B, C, D. It consists of edges A, B, C and D. Now if I add a chord H to this spanning tree. Now this is a spanning tree, so all the edges of this particular spanning tree are called branches, you know very well by now. And all the branches that, and all the edges that do not exist in this spanning tree are known as the chords. So now if I add chord H, this particular chord we are talking about, if I add the chord H to this spanning tree T1, so this forms a fundamental circuit. See, if I this red dashed line will remove that, denote that particular chord which does not exist in the spanning tree. So this, if I add this particular edge, chord H, this edge which is a chord because it is not a part of the spanning tree but it is a part of the connected graph. Now if I add this chord H to this spanning tree T1, what do I get? I get a fundamental circuit, right? Now when I get this particular fundamental circuit which is B, C DH. This is the circuit I'm talking about. When I added chord H to the spanning tree T1, this fundamental circuit I got. So this fundamental circuit I will highlight with a pencil. So this is the fundamental circuit which we are talking about. So I get a fundamental circuit BCHD, right? And now from this particular fundamental circuit, removal of any branch other than H. We will not remove the chord that has been recently added, and mind it, I am talking about the branch. So I have added a chord H to this particular spanning tree and I got a fundamental circuit. Now from this very fundamental circuit, if I remove a branch, I am talking about branch. So D, B, C are branches and H is a chord. So among D, B, C, I have to remove one such branch which again removes the circuit. So say for example, I remove the branch C. This particular branch, when I remove, you can see here that the graph again becomes circuitless and I get my second spanning tree T2. So this is the second spanning tree which I got after adding chord H to this spanning tree T1 and then removing the branch C from this particular graph obtained by adding chord H to the spanning tree T1, right? So after I added chord H to the spanning tree T1, I got a graph with this fundamental circuit. From this particular fundamental circuit, I removed the branch C and I got another spanning tree named as T2. Now this spanning tree has edges A, B, D, H. So this is the spanning tree A, B, D, H. So from the spanning tree T1, you saw how I obtained another spanning tree T2. So this generation of finding one spanning tree from another spanning tree by the addition of a chord and then deletion of an appropriate branch, right, is also known as cyclic interchange or elementary tree transformation. We call it cyclic interchange or elementary tree transformation. So this process of finding another spanning tree from one spanning tree by the addition of a chord to the already existing spanning tree and removal of an appropriate branch from that particular already existing spanning tree is called your cyclic interchange or elementary tree transformation. So this is what we did. We found a spanning tree from the connected graph. Then to this spanning tree T1, we added a chord H. After adding a chord H and obtaining a fundamental circuit, we removed an appropriate branch C from this fundamental circuit and we obtained another spanning tree T2. So this particular process is called your cyclic interchange or elementary tree transformation. So in this particular procedure, as you can see, instead of deleting branch C, now this time I deleted branch C and got the spanning tree T2. Now if instead of deleting branch C, if we had deleted branch D or branch B, we would have obtained two additional spanning trees. Like here you see, if instead of deleting branch C, I delete branch D, then I get this particular spanning tree T3 with the edges A, B, C and H. And instead of deleting branch C or D, if I delete branch D from the spanning tree T1, I will obtain another spanning tree, right? So this way we can obtain more than one spanning trees by adding a chord and deleting the appropriate branches from the fundamental circuit obtained by adding the chord, right? So see, as I told you, if I remove the branch D from this particular spanning tree, I get another spanning tree T4 A, D, H and C. So from this same spanning tree, I have obtained 3 more spanning trees. From the spanning tree T1, I have obtained spanning tree T2, T3 and T4 simply by adding a chord H to the spanning tree. And after obtaining a fundamental circuit by adding the chord H to the spanning tree, first of all I removed the branch C. Then I got the spanning tree T2. After removing branch D, I got the spanning tree T3, and after removing the branch B, as you can see here, I obtained the spanning tree T4. So this is how simple it is to obtain so many spanning trees from one spanning tree. Fine. Now, after generating these 3 trees, as you can see, I have generated 3 spanning trees from this one spanning tree. From the spanning tree T1, I have generated spanning tree T2, spanning tree T3 and spanning tree T4 just by removing branches C, D and B respectively. I removed branch C, I obtained spanning tree T2. I removed branch D, I obtained spanning tree T3. I removed branch B, I obtained spanning tree T4. So after generating these 3 trees, we can restart with T1. Now there is no more chord that can be, there is no more branch that can be deleted from the fundamental circuit obtained by adding chord H to spanning tree T1. We have obtained maximal 3 spanning trees from this particular spanning tree T1. We removed all the 3 branches one by one. First we removed branch C and obtained spanning tree T2. Then we removed branch B, then we removed branch D and obtained spanning tree T3. Then we removed branch B and obtained spanning tree T4. Now we can restart. Now we have no further branches to be removed to obtain a new spanning tree. So we will restart from T1 now, right? How we will restart? We will restart with T1 and a different chord will be added, because now we will add a different chord. With the same chord, we have already obtained 3 spanning trees by removing different branches at different times. Now we will add a different chord to the same spanning tree, right? So this time to this particular, consider this spanning tree only, the spanning tree T1. Earlier we added the chord H to this spanning tree. Now this time to the same spanning tree, instead of adding chord H, we are adding chord E, right? We added chord E, and this is the spanning tree that we obtained after adding chord E to the spanning tree T1. Earlier we had added the chord H, this time we are adding chord E, right? This is the chord we are talking about. E is a chord here. Now again a fundamental circuit is formed, and as I said, after I add a chord to the spanning tree, a fundamental circuit is formed, and from this particular fundamental circuit, when we remove an appropriate branch, we get another spanning tree, right? So thus we have a procedure for generating spanning trees for any given graph. So from this particular spanning tree, from this particular fundamental circuit ABE, we will remove one appropriate branch and we get another spanning tree. Say for example, if I remove the branch A, here you can see after the removal of branch A, this is the spanning tree I get, and I can name it spanning tree T5. So from this spanning tree, after adding chord E, we get a fundamental circuit, and from this fundamental circuit, after removing branch A, we get this spanning tree. Now from the same spanning tree, if instead of removing branch A, I remove branch B, I get this spanning tree T5, right? So this is how you can get spanning trees out of another spanning tree. Now instead of adding chord H or chord B, if I add chord G to this spanning tree T1, to the spanning tree T1, first we added chord H. Second time we added chord E. Now the third time we'll see by adding chord G. This time I'm not adding chord E or chord H. I added chord G to the spanning tree T1. So again a fundamental circuit B, C and G is formed here. This is the fundamental circuit I'm talking about. So again a fundamental circuit is here formed, and now from this fundamental circuit I will remove any appropriate branch and I get another spanning tree. Say for example, if I remove the branch I remove the branch B from this fundamental circuit, this is the spanning tree I get. Another spanning tree, say T6, I will get by removing the branch B from the spanning tree, to which chord G was added, and when a chord G was added to the spanning tree of fundamental circuit, BCG was formed, and then from this fundamental circuit BCG I removed the branch B and I got this spanning tree named as T6, right? Similarly, I can remove the branch C from this fundamental circuit, and then I will get another spanning tree. If I remove, say for example, branch C from this fundamental circuit, I will get a spanning tree like this, right? This is the spanning tree I will get if I remove branch C from this fundamental circuit. Remember, you have to remove the branches only from the fundamental circuit and nowhere else. First of all, you have to add a chord to the spanning tree. After adding a chord, a fundamental circuit will be formed, and then you have to remove an appropriate branch from this fundamental circuit only and nowhere else. So in all the three cases where I added chord H to the spanning tree T, I added chord E to the spanning tree T, I added chord G to the spanning tree T. So every time the fundamental circuits were formed here, like you can see, we added a appropriate branch from the fundamental circuit and then we obtained another spanning tree. So here you can see when I removed the branch C from the fundamental circuit BGC, I obtained another spanning tree which I can name T7. So this way you have seen that we found 7 spanning trees from the same connected graph. So this is how you can find all the spanning trees from a connected graph G. So this way, starting from any spanning tree, like here we started from spanning tree T1. Starting from any spanning tree of a graph G, we can obtain every spanning tree of the graph G by successive cyclic exchanges. So what are cyclic exchanges? Adding a chord to the spanning tree. After adding a chord to the spanning tree, the circuit that is obtained, the fundamental circuit that is obtained, removing an appropriate branch from the fundamental circuit, obtaining another spanning tree. This way, trying removing all the appropriate branches one by one from the given spanning tree, we from the given fundamental circuit we find 2 or 3 spanning trees. When no more spanning tree can be found by removing any further branches from the fundamental circuit, we add a new chord to the same spanning tree to obtain another fundamental circuit, and then from the same fundamental circuit we can obtain branches, we can delete branches one by one to obtain 2-3 more spanning trees, and this way we can keep adding new chords, obtain new fundamental circuits, and remove the branches one by one at a time from the fundamental circuit to obtain new spanning trees. So this is the way, this technique is called successive cyclic exchanges, and using these successive cyclic exchanges we can start from any spanning tree of a graph and we can obtain all the spanning trees of the graph by successive cyclic exchanges.